Welcome back to 3 Inquisitive Kids. In this video we will be talking about the properties of isosceles triangles, and this is part 1 of lesson 3 of chapter 11. And again, here's our course outline for this unit. In our last 2 lessons we learned about symmetry, what it is, and its properties. Our learning goals for today is to understand and master the properties of isosceles triangles, and explore and master the axial symmetry of isosceles triangles. So isosceles triangles are also symmetrical figures. Determine whether or not if the following figures are axis symmetric. Can you find out their axes of symmetry? Of course, this first image is not symmetric. The second image is symmetric, and its axis of symmetry would be right down the middle. This has an axis of symmetry that is vertical. This is not symmetrical. This image has multiple axes of symmetry, diagonal ones, vertical ones, and horizontal ones. And this picture, we haven't really learned about it yet, but this is not the type of symmetry that we have talked about. But yes, it is a type of symmetry. It's called rotational symmetry. This is the image that represents Hong Kong, and if we just had the flower in the middle, it would be symmetric. But on the outside, since it has some characters and the words Hong Kong, then it's making it not symmetric. And this is not symmetric because when you fold it across the middle or across horizontally, they do not overlap perfectly. What do the following pictures have in common? As you can see, this is the Eiffel Tower, and this looks like a bridge. So they are both isosceles triangles. As you can see that this is their base, and this is their 2 equal sides. And these are all isosceles triangles. We know that AB equals AC. Therefore, triangle ABC is an isosceles triangle. How would you label the different parts of an isosceles triangle? So this would be its vertex angle, the top angle. These 2 angles are the base angles. These 2 sides, who are the same, are the legs. And this is the base side. So the 2 equal sides would be the legs of this triangle. The remaining side would be the base. Angle A, the angle created by the legs, so the angle that is right between the 2 legs, is the vertex angle. Angle B and angle C, the remaining 2 angles, or the angles between each leg and the base, are the base angles. Is triangle ABC an axisymmetric figure? What is its axis of symmetry? An isosceles triangle is an axisymmetric figure. The line on which the crease lies is the axis of symmetry. What they did here was they took a rectangular piece of paper, they folded it in half, and then they cut like this. And then when you unfold the piece of paper that was cut it out, you get an isosceles triangle. If you really want to, you can also do this yourself. Fold the isosceles triangle ABC in half along the crease, and then find its overlapping line segments and angles. So what would be some of its overlapping line segments? Well, AB and AC are corresponding line segments. And of course, their lengths are equal, so they would be overlapping. So is BD and CD. They're both half of the base. And AD and AD. You might say that they are the same line, but triangles ABD and triangles ACD both share their line AD. Here it says overlapping angles. So angle B and angle C are overlapping angles. Angle BAD and angle CAD are also overlapping. And so is angle ADB and angle ADC. So here's some main points to clarify. Isosceles triangles are axisymmetric figures. Angle B equals angle C. Angle BAD equals CAD. So angle BAD, there's a line down the middle, equals angle CAD, which means that AD is the angle bisector of the vertex angle. Angle ADB equals angle ADC, which equals 90 degrees. AD is the height from the base. BD equals CD, which means that AD is a median of the base. In math, there are different types of medians. In statistics and probability, you might have heard something called a median from a set of data. In this case, the median we are talking about is, for example, if you have a triangle and you're trying to find the median of AB, you would go from this point, the opposite point, and connect a line down to the middle of AB to make, let's say, point C, and AC would equal CB. So that's the median. And as you can see, AD is splitting BC in half. Are these lines the same line though? So we have the angle bisector, the height, and the median. But are these lines actually the same line on an isosceles triangle? Well, in triangle ABC, because AD is an angle bisector of the vertex angle, angle BAD equals angle CAD. In triangle ABD and triangle ACD, AB equals AC, angle BAD equals angle CAD, AD equals AD because they both share that side. In using this information, and using what we learned about finding congruent triangles, we can conclude that triangle ABD is congruent to triangle ACD. Therefore, BD equals CD, angle ADB equals angle ADC, which equals 90 degrees. And of course, if this is 90 degrees, then AD is also the height, which means that AD is the angle bisector, median of the base, and the height of the base on triangle ABC. This is a very good example of how what we've already learned can come in handy when you are writing a derivation. So an isosceles triangle is an axisymmetric figure. The bisector of the vertex angle, the height on the base, and the median of the base are the same line. And the base angles of an isosceles triangle are equal. Now I want you to draw the bisector of the vertex angle of an isosceles triangle. Its base is median and its height. Do they all overlap? Well, if you start from point B, these are all different lines. For example, in this case, BF is the height, BD is the angle bisector, BE is the median. But here you have another isosceles triangle, and this time they split it right down the middle from the vertex angle, which is A. As you can see, AB equals AC. Angle BAC is being bisected. And since we can prove that triangle ABD and triangle ACD are congruent, then this angle has to be, these angles have to be the same. And so 180 degrees divided by 2 equals 90. If this is 90 degrees, then line AD has to be the height. On both sides of this axis of symmetry, it's the same. BD has to equal DC, which means that AD is also its median. We like to call it 3 lines in 1. Now, true or false? Number 1, the interior angles of an isosceles triangle must be acute. That is false. What if you have an isosceles triangle that is like this? In this case, this angle would be obtuse. And if you had an isosceles triangle like this angle would be 90 degrees. The base angles of an isosceles triangle can be an acute angle, a right angle, or an obtuse angle. That is wrong. First of all, we know that there are 2 base angles in an isosceles triangle. And let's say that they're both obtuse. So the smallest they can be is 91 degrees each, right? Because that's 1 degree more than 90 degrees. And so 91 plus 91 would equal 182, and that is already greater than the interior angle sum. And now that I think about it, it doesn't even have to be 91. It could be 90.0001, and then when you add them together, they are still always a little bit greater than the triangle interior sum. An obtuse angle cannot be an isosceles triangle. That is false, because look what we just drew over here. All the angle bisectors of an isosceles triangle must be perpendicular to the corresponding base. Here the answer is correct, but this question forgot to add the word vertex. So if we had the word vertex in here, it would be much clearer. The angle bisector, median, and height of an isosceles triangle are the same line. That is an X, because you never said it was the vertex angle bisector. So it could be from even a base angle. And if you drew it from a base angle, it would not be the same line. Number 6, the median of the base of an isosceles triangle must bisect the vertex angle. And that is correct. What are some ways you can create an isosceles triangle? I want you to follow the steps below. So take a rectangular piece of paper, fold it in half, and then you can cut a diagonal across and then unfold it to get a isosceles triangle. Or you can use a compass. This is a geometric tool that a lot of mathematicians use, and you might be starting to use it as you get into higher levels. If the interior angle of an isosceles triangle is 50 degrees, then the values of the base angles are... So according to the triangle interior angle sum theorem, let's say that the vertex angle is the one that's 50 degrees. Then each base angle would have to equal 65 degrees. And let's say that it's saying the base angle is 50 degrees. If one base angle is 50 degrees, the other base angle is also 50 degrees, and the vertex angle would have to be 80 degrees. So it's either 65 or 80. The answer is C. In triangle ABC, AB equals AC, point D is on AC, and BD equals BC equals AD. Find the values of angle A and angle C. Here's our solution. Because AB equals AC, BD equals BC equals AD, that's given. Angle ABC equals angle C, which equals angle BDC, and angle A would equal angle ABD, because we know that base angles have to be equal. So we can let angle A be x degrees. Here is where a little bit of algebra comes in. Because angle A plus angle ABD plus angle ADB equals 180 degrees, and also because angle BDC plus angle ADB equals 180 degrees, angle BDC would equal angle A plus angle ABD, which would equal 2x. Angle ABC equals angle C, which equals angle BDC, which equals 2x. So then x plus 2x equals 180 degrees, using the interior angle sum theorem. And we can find that x equals 36, which means that angle A equals 36 degrees, angle C equals 72 degrees. Remember, in this case, your answer would not be x equals 36. Example 3. In triangle ABC, AB equals AD equals DC. Angle BAD equals 26 degrees. Find the values of angle B and angle C. So I want you to find the values of angle B and angle C. We know that angle BAD equals 26 degrees. AB equals AD equals DC. So we can mark that out over here. So it seems like we actually have two isosceles triangles. One is obtuse and one is acute, but both of them have the same leg lengths. Well, we know that AB equals AD equals DC. Therefore, angle B would equal angle ADB, and angle C would equal angle DAC. We can let angle C be x, therefore angle DAC would also equal x. Angle B equals angle ADB, which equals angle C plus angle DAC, which equals 2x. And in this triangle, according to the triangle interior angle sum theorem, 2x plus 26 plus x equals 108 degrees. We can further simplify to get x equals 38.5. Just so you know, a lot of people, they get nervous. They think they did something wrong when they get a decimal or a really odd number. But if you know that you already did everything correctly, you don't have to worry about it. Be confident in your answer. Which therefore, angle C equals x, which equals 38.5 degrees, and angle B would equal 77 degrees. Given points D and E are on side BC of triangle ABC, and AB equals AC. As shown in the figure, given AD equals AE, prove BD equals CE. Given BD equals CE, F is the midpoint of DE. Prove AF is perpendicular to BC. So I really want you to try out at least one of these questions, and it's even better if you challenge yourself to do two. But doing these questions will really improve your ability to write out clear solutions and your logical and abstract thinking. So as shown in figure 1, we can make AG perpendicular to BC from A. So we are making an auxiliary line. It's a helpful tool in math. It's like a guideline. Because AB equals AC, AD equals AE, BG equals CG, DG equals EG. BG minus DG equals CG minus EG, which means that BD equals CE. And for number 2, VD equals CE. F is the midpoint of DE. Therefore, BD plus DF equals CE plus EF. Therefore, BF equals CF. And because AB equals AC, therefore AF is perpendicular to BC. So many times it becomes necessary to add auxiliary lines. Common auxiliary lines can be the bisector of the vertex angle, the height from the base, and the median on the base. And now you can use all 3 auxiliary lines to help you later on because we just learned about it. Class summary. Today we learned about properties of isosceles triangles. So we know that their 2 base angles of an isosceles triangle are equal. And the bisector of the vertex angle, the median of the base, and the height are actually the same line. I hope you learned something from this video and be sure to come back for the next lesson.